The graph shows information about part of a cyclist's journey, and we can see that graph here. And we need to work out an estimate of the speed in meters per second of the cyclist at time of 6 seconds. So for a distance time graph, which is what we got here, because we got time plotted against distance, speed is represented by the gradient. So we need to work out the gradient at t equals 6, because we're looking at 6 seconds. And we can do this by drawing a tangent. So looking at time as 6, we've got this point here. So to draw a tangent at this point, we want to draw a straight line, so it only touches at that point. So I'm going to draw a line here, try and get it to line up. So at t is 6. Right, so this is the best that I could come up with. And obviously it's quite difficult doing this by hand. There is a bit of leeway in the mark scheme. Okay, so we now need to work out the tangent of this gradient. So I'm going to find 2 points. So let's have a look. If I choose here, if we go 4 on the x-axis, we go up here, it goes to this point here, which is 3.5. And let's choose another nice point. So if I look up here, let's say at t is 7, we'll be up at this point. And if we look along, that's at 13.5. Now the gradient of a line is the change in y over the change in x. So we can think about it like this. And we often represent that with the symbol m. So I could say, okay, for our case, our gradient, if we do change in y, that's 13.5 minus 3.5 divided by our change in x. So that's 7 minus 4. Now it doesn't matter which way around we did it, but we got to be consistent. So we can see we've got 7 and 13.5. This is a pair and this is a pair. So we always got to have a pair together here and a pair together here, and make sure we don't mismatch it and get it muddled up. So on the bottom here, we're going to have 3, and on the top, we're going to have 10. And that equals 3.33 to 2 decimal places. So our answer is 3.33 meters per second. Now we get our first mark up here for drawing the tangent, 1 mark down here for working out the gradient, and a third and final mark for a correct answer. Now, because everyone might have drawn the tangent slightly differently, the correct answer could be anywhere in the range of 3.05 to 3.7.